Hey Vikings, we're back. Soon I'll have to teach like this, but for now, let's go ahead and do another video. Today we're going to start off by talking about integers. Integers, not grr like a tiger, so don't say it wrong. It's integers. You don't want to be that person. It's kind of like ordering a side of jalapenos. Don't do it. Integers are positive numbers, negative numbers, it's all the whole numbers, positive and negative, plus zero. Zero is weird. It's not positive, it's not negative. It's kind of like Switzerland. In World War II, Switzerland didn't fight with the Germans, didn't fight with the US. It was neutral. Next we're going to be talking about rational numbers. Now, that was kind of crazy because we just looked at the ceiling. I'm sorry, the thing fell over. Rational numbers can be written like a ratio. That's a fraction. If it's a number that you can write it like a fraction, 2 on top, 3 on bottom, 2/3, or maybe you've got 0.5. 0.5, what's that? Well, that's half. So 1/2. What about 4/4? Well, 4 divided by 4 is 1. So all the whole numbers are also rational numbers. But that means that we now can use the numbers in between the numbers. So they are the numbers that exist between the integers. The numbers that exist between the integers are rational numbers. It's the little things, the ones that have parts with them. Kind of like you go to the store, it might be priced $1 because it's the dollar store, but then you have to pay $1.08 because of tax. What's with the tax? The tax is the rational part of the thing. Is it rational to pay tax? Ask the government. So, let's move on. So, inequalities. You remember Chompy the crocodile? Chompy wants to eat the big numbers, Chompy wants to eat the big numbers. Well, Chompy the crocodile, that's what we're talking about with inequalities. It's the big number goes on the side where the mouth is. The big number goes on the side where the mouth is. Big number over here, little number over there. Little number over here, big number over there. Inequalities. That's what you use when things aren't equal. If 5 is on one side and 5 is on the other side, that's an equality. Equalities are when the numbers are the same. Inequalities are when you have 5 and 4. 4 is lower, so Chompy the alligator would want to eat this hand, not that one. One way to remember these, which one's greater than, which one's less than? Well, there's the alligator crocodile thing. Watch this. This is awesome. Greater than. That one's greater than. What about the other one? Does that work too? You bet it does. Less than. So, if you're trying to remember which one's greater than and which one's less than, try to make your G or your L greater than and less than. There are inequality signs. Which number's bigger? Which number's smaller? Well, let's think about this. If you have negative $5 and I have negative $20, negative 20 is further to the left from 0 on the number line. So that means my number is smaller. But that's a bigger debt. Funny how that works. Bigger debt means more negative. Let's talk about the number line some more. pre-made number line. Imagine that. So, as we travel down the number line, the further we go to the right, the bigger numbers get. 2 is bigger than 1. If we go left, the numbers get smaller. So it's -1. -1's further to the left. -2's further to the left than -1. You could keep going. Somewhere down there, we're going to have another number. Maybe you go a long way. -22. That's a far distance from 0. To go from 0 to -22 is a distance of 22 units. But is 2 bigger than 22? Only when the 22 is negative. -22, further to the left. Regular old 2, further to the right. Number on the right, always the bigger number. So if they're asking for the bigger number, you're right if you answer the number that's on the right. Where do the rational numbers sit on this thing? Halfway between -1 and -2 is -1 and a half. Halfway between -1 and 0. -half. It keeps going. And if you fold it down the middle, right at the 0, they fold together and match up with their opposite numbers. The opposite of 5 is -5. The opposite of 3 is -3. The opposite of 3,689 is -3,689. So, what's the opposite of negative 6 5/8? The opposite of -6 5/8 would be, you guessed it, positive 6 5/8. Positive 6 5/8 is a rational number because we can write that as a ratio. 6 5/8. The 5/8 is a ratio. Are there numbers that aren't rational? Yes. Are we going to worry about them this year? No. In fact, there's these crazy numbers called imaginary numbers. Mathematicians get so wrapped up in this stuff that they create numbers that aren't real and are imaginary. But we all agree that they exist because mathematicians like numbers that much. What about some more regular integers and rational numbers? The number 3/4. If you have 3/4, how much money is that? 3/4 written as a fraction is 3/4. That's a rational number. But how much money is that? 0.75. 75 hundredths. So if you have a dollar bill and you divide it into 75, if you have a dollar bill and you divide it into 100 pieces and you have 75 of those pieces, that means you have 75 pennies. Those 75 pennies, then you could convert them to 3/4. 3/4. 3/4. 3/4 is 3/4. Pretty cool. How about another number? Another rational number? One half? Well, what is 1/2 as a decimal? The answer is Curtis Jackson, 50 cents. Do you have to write the 0? No. Why? Because mathematicians are lazy. So, this is the same thing. 0.50, 0.5. Which one sounds better? I don't know. 0.50 sounds like somebody with like the party lights on top of their car might be showing up. Let's stick with 0.5. Then we don't have to write the 0. Mathematicians are lazy.